Hi everybody, I hope you are okay and do amazing. Here chapter 1 of the organic chemistry, and we will talk about atom and bonds. As a starting, the organic chemistry is a chemistry of compounds that contain the elements carbon. Is one branch in the entire field of chemistry. Organic compounds constitute most of the materials associated with living organisms. The principal source of the carbon in living things is carbon dioxide, which is converted to simple chemical by green plants by photosynthesis. Here it is clear from this picture that the plant need to the sunlight and carbon dioxide with the water and give you the glucose and the oxygen. Of course, the glucose is the organic compound and is one of the resource starting material for other compounds. These simple chemicals are converted to multitude of natural products. He mean here the glucose and other compounds by the metabolic process of plant and animals. The chief sources of organic material are coal, petroleum, wood, and agricultural products. These are fundamental raw materials upon which the organic chemical industry is built. They also constitute a huge reservoir of the storage of solar energy. This energy can be released by composition of the organic compounds with the liberation of heat. The fundamental energy cycle can be illustrated by means of the two highly simplified equations. Here we have the organic compound plus O2 oxygen by the combination احتراق give you what? CO2 H2O and heat. This heat it will be converted to other energy, and the CO2 and the H2O will be go again to the plant by photosynthesis and the sunlight. Organic chemicals are put to many varied uses. They are worn as cloth, eaten as foods, used as both fuel and cosmetic acid. They include drugs, vitamins, and hormones used in agriculture as fertilizer, soil conditioners, and insecticides. Perhaps the best way to appreciate the variety of organic molecules is to look at a few. Three simple organic compounds are methane, ethanol, and trichlorofluoromethane. Look here, you have three compounds: methane, ethanol, and trichlorofluoromethane. There are a huge difference between of them. Okay, there are big difference between of them. Then the methane is gas and constituted from the carbon atom and 4 hydrogen atoms, and they have different properties, chemical properties, and different uses in our lives. And the second one is the ethanol, also consisted of two carbon atoms and 1, 3, 4, 5, 6, 7 hydrogen atoms with the oxygen atom, and also have different properties, chemical properties, physical properties, and different uses in our life. And the last one is the trichlorofluoromethane, is constituted from the carbon atom and 3 chloro atoms with fluoro, and also has different chemical physical properties and different uses in our life. The periodic tables. All matter is composed of the same building blocks called atoms. There are two main components of the atoms. The nucleus, here the nucleus in the center contains positively charged protons and uncharged neutrons. Here inside the nucleus we have protons with positive charge, and we have neutrons is uncharged without any charge, neutral neutral parts. Also we have the electron. A cloud is composed of negatively charged electrons. Here around the nucleus it is a cloud. A cloud يعني عور غائم. Okay, this cloud contains from the electron is negatively charged. The electron cloud comprises most of the volume of the atom. That meaning more electrons, that meaning the atoms it will be bigger. In a neutral atom without charge, the number of protons in the nucleus equal to the number of the electrons. Number of protons equal to the number of electrons. 5 proton positive, it will be 5 electron negative in the other side. That meaning this atom it will be neutral atom without any charge. Okay, 4 proton to the 4 electron, 2 proton, 2 electron, 1 and 1 electron. In this case the atom it will be uncharged, and called this number called the atomic number. I told you what is the atomic number. Here the answer it will be number of proton is equal to number of electron in the atoms. Okay, is unequal to the particular elements. For example, polynuclear carbon atoms has an atomic number of 6, meaning it has 6 protons and it is nucleus and 6 electrons surrounding the nucleus. Then we said we have neutral atom, and we have 2 other different cases. We have negatively charged atom is called anion, and we have positively charged atom is called cation. Cation is positively charged and has fewer electron than its neutral form. Fewer electron, that meaning here the number of protons is more than the number of electrons. For this reason it will give you positive charge. The other side, an ion has number of electron more than the number of proton. In this case the atoms it will be take a negative charge. Isotopes. Isotopes meaning النظائر, and the number here, the isotopes, the division is the number of neutrons in the nucleus of a particular element can vary. Isotopes are isotopes are 2 atoms in the same elements, not meaning same element, meaning carbon, the same for carbon, okay, having different number of neutron. That meaning we have, for example, carbon 12 and we have carbon 13, both of them carbon, but the mass number is different. The mass number of atom is total number of proton and neutrons in the nucleus. Isotopes has different mass number. For mass number equal to the number of proton plus number of neutrons and equal to the atomic weight. Look, number of proton plus to the number of neutrons. And for example, we will take the carbon 12. Carbon 12 have 6 proton and 6 neutron. That meaning the mass number will be 12. And we have carbon 13. Carbon 13 has 6 protons and 7 neutrons. For this reason the mass number it will be 13. Okay, and the most common isotopes of the hydrogen has 1 proton and no neutrons. This is the most common of the hydrogen, called the proton, okay, in the nucleus. But 0.02% of the hydrogen atoms has 1 proton and 1 neutron. This isotopes of the hydrogen is called deuterium. Okay, one proton and one neutron. Look, one proton and one neutron. Okay, and we have third figure of the hydrogen has one proton and two neutrons. Is tritium. All of this is hydrogen, but isotopes. Here the difference between this and this and this, the number of the neutron. Okay, and the difference between of them is the mass number. A periodic table of a common elements seen in organic chemistry. This the famous atoms we used in the organic chemistry. How you can see, we can see these atoms during your organic chemistry study. Okay, and we have this, the first row, second row, third, fourth, and we have first group, second group, third group, 4, 5, 6, like that. And look to carbon here, the carbon, the position of carbon in the second row, and fourth group number 4. This is the position of the carbon. Okay, the element in the same row, for example this lithium in the same row, barium, carbon, nitrogen, oxygen, fluor, has similar size. This is similar in size, نفس الحجم. Also this is similar in size. And the elements in the same column has similar electronic and chemical properties. That meaning this group is the halogen, and the halogen has similar chemical properties, has high electronegativity. Here or this group is positively charged, one positive charge. The second group is all the atoms here has two positive charge, positively charged. The structure theory. Two central premises are fundamental. That meaning we have two principles here. The first one is the atom in organic compounds can form fixed number of bonds. That meaning one atom can be make one bond, and the other can be make two bonds. Other atom can be make three bonds, and like that. The other make four bonds. The measure of this ability is called valence. That meaning valence is the ability of the atom to make bond with other atoms. To form what? To form molecule. Carbon is tetravalent. Okay, that meaning the carbon make four bonds. Tetra meaning four. Tetra. That is carbon atoms form four bonds. Oxygen is divalent. Di meaning two. And the hydrogen and usually the halogen with the hydrogen are monovalent. Monovalent meaning just one mono meaning one, and can be make one bond with other atoms. The second row here is a carbon atom can use one or more of its valence to form what? Bonds to other carbon atoms. The meaning here, the carbon can be make bond with carbon and with other atoms also, or can we make double bond with the neighboring carbon. Okay, this carbon mujawira, neighboring carbon, or can we make three bonds, but all of them is tetravalent. Look to this carbon, one bond to here and three bond, it will be four, and also here 1 2 3 4. Okay, we have here one bond absent, talaba. You can put here line from this side and from this side, and also this carbon, and we have two bonds here from the down, and two bonds here and one bond here. Bonding. The simplest definition of the bonding is the joining of two atoms in a stable arrangement. Okay, يعني the best figure to bond between two atoms to make a molecule. Bonding may occur between atoms of the same or different elements. Bonding here meaning can carbon bond with the carbon, or the hydrogen with the hydrogen, or the hydrogen with carbon, and the carbon with halogen, the same or different elements, okay, can be occur between of them. Bonding is favorable process because it always lead to lower energy and increase stability. Always the bonding lead to the lower energy and increase stability. Joining two or more elements form compounds. Through bonding, atom attain a complete outer shell of the valence electron. What meaning that? Meaning, for example, the hydrogen atom has just one shell of electrons, is the 1s, and the 1s need two electrons to be stable, okay, to be completed. For this reason, the hydrogen make bond with the other atom, for example another hydrogen. All of them, one of them is give one electron and the other give one the second electron, and make one bond between of them, and for everyone it will be two electrons in the valence, in the outer valence of the atom. In this case it will be stable. The greatest stability is reached when the outer shell المدار الخارجي is full with what? With 8 electrons, as in noble gas. Noble gas, the last group in the periodic table, okay, from the right side of the periodic table. All these gases in that group is inert gas, cannot be react with other atoms. For this reason they called noble gas. Both ionic and covalent bond arise from the tendency of the atom to attain this stable configuration of the electron. We call the tendency for an atom of achieve a configuration where its valence shell contain 8 electrons, the octet rule قاعدة. Okay, هذا قاعدة. The octet rule meaning the tendency of the atom to achieve the saturated configuration in the outer shell with 8 electrons, like the noble gas. Okay, like the noble gases. And here another definition for the bonding, the same thing. And there are two different kinds of bonding: ionic bonding and equivalent bonding. Okay, and we learn for the next slide what meaning the ionic bonds and the covalent bonds. And as a sample definition for the ionic and covalent, the ionic bonds result from the transfer of the electrons from one element to another. Transfer, okay, here this word is very important in the ionic bond. That meaning for every time when you think for the ionic bond, you have to put a transfer of electron from one atom to another. And for equivalent bond, the equivalent bond heat result from the sharing of electron between two nucleus. That means we don't have transfer, we have sharing of electron. One atom give electron and the other atom also give electron. Okay, I will give you money and also you will give me money, like that, sharing the electrons between the atom. And here the ionic bond, again ionic bonds result from transfer of the electron from one element here to another. The type of bonding is determined by the location of an element in the periodic table. Look, the type of bonding is determined by the location of the element in the periodic table. An ionic bond here this sentence is so important. Okay, and then for example, the first group and second group always make ionic bond, and the last groups for the halogen, carbons, silicon and boron make sulfur also make always covalent bonds. An ionic bond generally occurs when elements on the far left side, far left side, if you look to the periodic table on the left side, okay, on the left side of periodic table combine with the elements on the far right side of the periodic table. That meaning the ionic bond can be occurred between elements from the left side with the elements from the right side. Okay, ignoring the noble gas, expect the noble gas, because the noble gas is, I said to you before that, inert gases cannot be react with the other atoms. The resulting ions are held together by extremely strong electrostatic interaction. Okay, electrostatic interaction, like we can say like magnetic, like that. Okay, we can, because we have positive negative, okay, between the two atoms. Okay, a positively charged cation formed from the elements on the left side attract a negatively charged anion from the formed from the elements on the right side. Okay, the resulting salts are seen in many of the organic compounds. That means, look to the sodium from the left side, bond with the chlor from the right side, and the result of bonding between of them is a salt. Okay, salt can be seen in the inorganic chemistry, not in the organic chemistry. Okay, sodium chloride NaCl is the common table salt, and potassium iodide is an essential nutrient added to make iodized salt. Also, lithium fluoride, here lithium fluoride is an example of ionic compound. The elements lithium located in the group number 1 of the periodic table has just one valence electron in its second shell. If this electron is lost, lithium form the cation. Okay, if this one electron will be transferred to the fluor, that meaning the lithium it will be cation, positively charged, having no electron in the second shell. Okay, however, it will have a stable electronic arrangement with 2 electrons in the first shell, like helium. Look, lithium fluoride ionic bond, because the lithium it will be positive and the fluor it will be negative. Okay, here's the example. The lithium has 1 electron in the valence shell, the valence electron, the outer shell. Okay, if we remove this electron from the lithium here, it will be give you positively charged lithium, positively charged cation. The fluor on the other side, take the electron, it will be negatively charged. Okay, in this case the positive and the negative it will be bond together, electrostatic interaction like magnetic. Okay طلبة, and give you the ionic bond. Covalent bonds. Covalent bonds result from the sharing, again I say to you, sharing of electron between 2 nucleus. When 2 or more elements like carbon in the middle of the periodic table reacted, a complete transfer of the electrons doesn't occur. In this instance, the atom achieves a noble gas configuration by sharing electrons. Covalent bonds form between the atoms, and the products are called molecules. some examples are shown here. I will give you examples. This one hydrogen atom with one electron, and also here one hydrogen atom with one electron. Both of them, it will be sharing their electrons to make bond. The bond with also the bond formed from two electrons. Look to here. The hydrogen, okay, and the fluor also make covalent bonds. This hydrogen gives this electron and the fluor give this electron. For the fluor, if you calculate 1 2 3 4 5 6 7 8, it will be like noble gas. Okay, for this reason it will be stable and form covalent bond. Here you have examples. Label each bond in the following compounds as ionic or covalent bonds. For the F2, of course, it will be covalent because the F2 from the right side, and lithium Br, it will be covalent bond because the lithium is metal from the left side of the periodic table, and the boron from the right side. And here between the carbon is covalent, carbon hydrogen, all the bonds here in this compound is covalent bond. There is no positive negative charge. Here the sodium nitrogen bond, it will be ionic bond, and for the nitrogen hydrogen it will be covalent bond. Lewis structure. طلبة, I will stop here and we will take this subject inshallah in the next lecture. See you and have a good night.